Alright, in this problem we want to find the limit as x approaches 0 of 6x times sine of 6 over x squared. Now the real key here is to focus on the right part. So you want to not focus on the argument of the sine, that is the 6 over x squared, because sine of anything is between negative 1 and 1. So that's a good place to start. So it doesn't matter what's inside the sine of anything is always between negative 1 and 1. So instead you want to really try to figure out your upper and lower functions based on the 6x out here. So I start with this inequality, and then to get our function f of x in the middle, we need to multiply all three sides by 6x. But if we multiply by 6x, now x could be positive or negative, and that could alter the direction of the inequality sign. So you can put 6x by itself in the middle, but on the upper and lower parts here you need to put absolute value bars to make sure that this function is in fact always positive, and then that this function is always negative, which you get by putting the negative outside the absolute value bars. That way the direction of the inequality signs will be correct. So you're going to call that your lower function, and then this your upper function. And we're hoping, right, that at this point they both have the same limit as x approaches 0. But they do, because as x approaches 0, the absolute value of x approaches 0, and 6 or negative 6 times that will also approach 0. So the upper and lower functions both have a limit of 0, and so therefore by the squeeze theorem, our function also has a limit of 0, which we can also check by checking out the graph. Alright, here's the graph of 6x times sine of 6 over x squared. So you can clearly see that the limit is 0 as x approaches 0 from both the right and the left. And here it is with the absolute value function. So this red one is the absolute value of 6x, which you can see visually is always above our function. It also has a limit of 0 as x approaches 0. And the negative of the absolute value of 6x is down here, which is always below our function.